So we've been talking about the area between two curves. Now I'm going to use this next example as 3 and 4. We're going to do it twice using two different methods. So what we're going to do is we're going to find the area of the shaded region of the graph. Here, if you notice, I've got a blue line, which is y equals x plus 8, and this red line, which is y equals 8 minus 2x. I'm looking for the shaded region in the first and second quadrants of this green part right here. Now, the first method I'm going to show you is going to be pretty straightforward. What I'm going to do is I'm going to split this shape, this region, along the y-axis. Since it's two different functions and they intersect here, what I can do is I can focus just on the left side of the y-axis. So this area under the blue line, y equals x plus 8, and then I can add it to the area under the red line, which is y equals 8 minus 2x. That gives me the right side of the graph. So again, what I'm going to do is I'm going to do two different integrals, and then I'm going to add them up. So the first integral on the left side, we're going to go from -8 to 0. That's going to give me this triangle on the left. And I'm going to do just the area under x plus 8 dx. Okay, so integrate that. We're going to do 1/2 of x squared plus 8x, evaluated from -8 to 0. And that's going to give me 1/2 of 0 squared plus 8 times 0. Then we're going to subtract 1/2 of -8 squared plus 8 times -8. Okay, so that's going to go to 0. And this is going to be negative 1/2 of -8 squared. -8 squared is 64, so positive 32, and that's going to be negative 64. 32 minus 64 gives me negative 32, and we already had that negative out front. So my answer for this part of the area is 32. Again, you could have calculated that as a triangle, but I was just going to do it this way just to be sure we did definite integrals. So I know the left side is 32. Now I'm going to do the right side, the other side, so this part over here. So this case, I'm going to go from 0 to 4, and I'm going to use the red function because that's the upper bound in this case for that other area, that other region. And so we're going to have 8x minus 1/2 of 2 is just 1, so that's going to be x squared, evaluated from 0 to 4. So we're going to plug in 8 times 4 minus 4 squared. And then we're going to subtract 8 times 0 minus 0 squared. That's just going to disappear. 8 times 4 is 32. 4 squared is 16. 32 minus 16 gives me 16. So the area of the other side, again, it's a triangle. You could have calculated it using geometry, but I know that that's 16. So together, they make a total area of 48. So that's the area of the green region. Now, I'm going to come back in another second, and we're going to do example number 4, where I do this exact same problem using a different method.